You are tuned in to The Low Band Show, broadcasting from the storm drains under the big city, where a tunnel crew runs this booth on salvaged gear, pipes humming, steady water dripping, piping surface science and tech news on a low band signal through the drains. I'm your host, Max Hertz. Welcome in. Here's what we do. We take real science and tech news from the surface, summarize it, then go deeper to educate, entertain, and shed light on what's in store for our collective future. News from the net, clear signal, and a little tunnel. If you came for hype, you took a wrong turn at the storm drain. Welcome in, everyone. Good to have you down here with us today. Wiz, glad you could make it to the booth.
Glad to be here, Max. I'm ready to dig into what's on the board today.
We've got a fascinating lineup of stories today, spanning everything from mysterious biology to the deepest reaches of space and the cutting edge of AI. We'll start with a strange mushroom causing tiny human visions that seems to lack the genes for any known psychedelic compounds, and then look at potential signs of ancient microbial life that NASA's Rover spotted on Mars. After that, we'll check out the first ever detected fingerprints of a black hole's event horizon before discussing the government's limited release approval for Anthropic's new Mythos model. We will wrap up with how the Linux Foundation is tackling AI-driven open source security with their new Akrites initiative. Let's get into it. Science Alert reported on June 19, 2009, about an extraordinary wild mushroom in China. The headline points to a fungus that causes visions of tiny people, but completely lacks the genes for any known psychedelics. This matters because finding a new pathway could reshape neurobiology. Wiz, have you ever heard of Lilliput-sized hallucinations?
I've read the reports. It's a trip to Lilliput in real life, courtesy of a mushroom genus called Lanmowoa. Undercooked, it makes people see miniature human beings. It's a fascinating mystery.
Here is the first excerpt. To try and find out the root cause, University of Utah mycologists Colin Domnauer and Bryn Dentinger sequenced the genomes of 53 mushroom samples. They found no close matches to genes associated with psilocybin or ibotenic acid. Wiz, for listeners who may not know, what is Lanmowoa?
It is a genus of wild bolete mushrooms native to East Asia. Normally, undercooked specimens can trigger vivid visual hallucinations of tiny people, but they are somehow doing it without the typical active compounds.
The researchers write in their published paper, biosynthetic gene mining of the L. asiatica genome found no close hits with any genes known in the production of mushroom psychoactive compounds. This supports our hypothesis of the presence of a novel, unidentified metabolite.
So the researchers basically mined the entire genome and hit a wall. It means we are looking at a completely novel compound that science hasn't identified yet. That is a massive deal for neurochemistry.
The paper notes that they identified 1,515 corresponding genes, allowing them to map out 17 recognized species in the Lanmowoa genus, including two newly named ones, Lanmowoa fallax and Lanmowoa carbonivore.
The evolutionary mapping is fantastic work, but the real holy grail here is that unidentified chemical culprit. It's a brand new pharmacology target waiting to be discovered.
Whether scientists can isolate this compound remains to be seen. The actual mechanism of these visions is still unknown. We will be right back after this. The headline promises a sign of life on Mars. Let's see what the paper actually says. The Guardian reported on June 24, 2026, that NASA's Perseverance rover has detected complex organic carbon in ancient Martian mudstones. Wiz, the material was identified in the Bright Angel outcrop, described as a dried-up river that carried water into the planet's Jezero crater billions of years ago.
Organic carbon in a dried-up Martian river. Before everyone starts planning the welcome parade, remember that organic is a chemical description, not a biological guarantee. It means carbon-bearing, which is the baseline recipe for life, but geological processes can bake that same cake without any microbes involved.
That's the crux.
The report explains the form of carbon detected, known as macromolecular carbon, or MMC, can originate from living organisms, but adds that rock and water reactions or meteorites can also produce it. Dr. Ashley Murphy noted it can originate from biological sources found in microbial mats and coal. Wiz, for listeners who don't live in a lab, what actually is macromolecular carbon?
It's basically giant, complex networks of carbon atoms bonded together. On Earth, we see those macromolecules in organic materials, like the coal and microbial mats you just mentioned. But as you read, geologic chemistry or incoming meteorites can build those exact same structures. It's a clue, not a smoking gun.
Exactly. But these rocks already have a history. The report notes that this same Bright Angel outcrop caused a stir in 2024 when the Perseverance rover discovered intriguing surface spots and nodules. When details were published last year, Sean Duffy, the former acting head of NASA, said, "This very well could be the clearest sign of life that we've ever found on Mars."
That's a massive statement. But look at the verbs. Could be is doing some heavy lifting there. Spotty rocks and complex carbon are exactly what you'd expect to find if Mars once had life, but they are also exactly what you'd expect from active geology. It's a tantalizing overlap, not a finished case.
Right, and this isn't just an isolated pocket. The authors write in Science Advances that finding these organic-bearing mudstones thousands of miles apart indicates that the habitability of Mars and the availability of organics may have been widespread across the planet billions of years ago.
Now that is the real story. We're not just looking at one lucky puddle in Jezero Crater. We're talking about a planet-wide distribution of organic building blocks. Mars had the water and the chemistry everywhere. It was fully open for business, even if we don't know if anyone ever moved in.
Ultimately, whether these carbon signatures truly point to ancient life remains to be seen. It's still early days, and the chemistry is too complex to call without returning samples to Earth. We'll be right back with more after this short break. This one made me sit up. The boundary of a black hole has always felt like science fiction, but we might have just touched it. Nature published research on June 24, 2026, detecting gravitational wave fingerprints of an event horizon. This matters for testing general relativity. Wiz, are we really looking past the point of no return?
Physically, we are looking at the gravitational echo of that boundary. The event horizon itself is still a one-way street, but the space right outside it is a noisy, violent neighborhood, and we finally have the ears to hear it.
Here is how they did it. The team analyzed data from the strongest gravitational wave ever recorded, known as GW250114, detected in January 2025. By isolating the last burst of waves, called direct waves, from this black hole merger, scientists extracted information closer to the horizon than ever.
And that is the breakthrough. Usually the signal is a messy blur, but isolating those final direct waves is like catching the last, purest ring of a struck bell right before it goes silent.
Lead author Sijang Ma of the Perimeter Institute compared this to a spoon stirring water, offering a chance to decode the physics of that region. Wiz, they also detected frame dragging around the black hole. For listeners who may not know, what does that actually mean?
It is Einstein's idea that a massive spinning object literally drags the fabric of space-time around with it. Think of spinning a heavy ball on a trampoline. The canvas twists. Near a rotating black hole, space itself gets wound up like a tight coil.
The team hopes to find signs of quantum fluctuations next. Ma noted that by probing this near-horizon region, we can look for new physics, including searching for a deviation from general relativity.
Now that is where the real fun begins. Relativity has passed every test for a century, but we know it breaks down at quantum scales. If we find a deviation there, we are looking at the holy grail of physics.
That is the promise, but it is still early days. Whether these waves can actually reveal quantum fluctuations remains to be seen, and the exact limits of this detection method are still unknown. We will be right back after this.
The fight here is really about national security versus commercial AI access. CNN reported on June 27, 2026, that the federal government is greenlighting a limited release of Anthropic's new model. Wiz, what do you make of this sudden turnaround?
It looks like a classic bureaucratic pivot. They hit the panic button with an export ban earlier this month, and now they are quietly backtracking. They want the security control, but they can't afford to stifle the developers.
Let's look at the details. CNN reports, quote, the U.S. government has allowed Anthropic to release its powerful Mythos AI model to select companies and organizations, revising license requirements after ordering an export block earlier this month. Wiz, for listeners who don't follow this closely, what is Anthropic's role here?
Anthropic is a major AI safety and research lab, famous for their Claude models. Mythos is their latest, high-end system, designed with advanced reasoning capabilities. This isn't your standard chatbot. It's built for heavy-duty computation.
Lutnick justified the decision in a letter on Friday. Quote, I have determined that appropriate safeguards are in place to permit certain trusting partners to access the Claude Mythos 5 model. Wiz, how do you verify appropriate safeguards in a closed-door deal like this?
You don't. It's security theater mixed with defense pragmatism. They are letting trusted partners, likely federal agencies and key defense contractors, do the testing because they need the defensive capabilities immediately. The government realizes they can't defend infrastructure with outdated tools.
The permission doesn't cover everything. The letter excludes Fable, a less powerful version. Anthropic stated, quote, we received notice from the U.S. government that Mythos 5, our strongest cybersecurity model, can be redeployed to a small group of cyber defenders. Wiz, why release the stronger model, but keep the weaker one locked down?
Because Mythos 5 is specialized for cybersecurity defense. Cyber defenders need the absolute best tool to patch vulnerabilities. Fable is likely a more general-purpose model with broader export potential, which means wider exposure and higher risk of dual-use leakage. It's a risk mitigation play.
Negotiations are expected to continue into the weekend. Whether the government and Anthropic can find a permanent framework for these models remains to be seen, and the exact criteria for trusted partners are still unknown. We will be right back after this. The Linux Foundation announced a new security initiative called Akrites on June 25, 2026. This matters because AI is supercharging vulnerability discovery. Wiz, for listeners who don't know, what exactly is the Linux Foundation's role here?
They are the neutral nonprofit that hosts and coordinates critical open source projects, including the Linux kernel itself. In this case, they are bringing together the biggest tech companies to build a unified defense line. It is a massive play to keep shared code from crumbling.
The announcement says Akrites will provide, quote, a shared security incident response team, a standardized coordinated vulnerability disclosure process, and act as a maintainer of last resort for abandoned but widely used packages. Wiz, for listeners who might not know, what does a SIRT actually do?
Think of it as a digital fire department. When a security vulnerability is found, they coordinate the alarm, work on the patch, and make sure it is safely rolled out before bad actors can exploit it. It prevents the chaos of uncoordinated fixes.
They are positioning this as a historic shift. The Linux Foundation wrote, quote, Akrites is the largest coordinated effort in history to create systems and deploy tooling that leverages the collective power of the community to make everyone safer. Wiz, is that realistic or just marketing hype?
It's a bit of both. The scale is real. You have players like AWS, Google, Microsoft, and NVIDIA at the table. But the real challenge isn't creating the committee. It's getting these fierce rivals to actually share threat intelligence in real time.
To that point, the letter states, quote, Akrites participants will contribute engineering resources, work to build and ship fixes, or fund the engineers who do. Wiz, does this rescue mission risk giving tech giants too much control over the open source ecosystem?
Absolutely. When megacorporations fund the maintainers of last resort, they gain immense leverage over which projects survive. It is a vital safety net, but we have to watch who holds the keys to the kingdom.
Whether this corporate coalition can truly secure open source without centralizing control remains to be seen. It is still early days for Akrites, and the long-term impact on independent maintainers is unclear. We will be right back after this. That is our board for today, and it is a fascinating lineup of boundaries being tested. We started with the mystery of those Lamnoa mushrooms and the chemistry behind those tiny human visions. Then we looked out at the solar system, weighing Martian mudstones against volcanic chemistry, before diving into the event horizon of a black hole to search for deviations in general relativity. Both remind us how much we still have to learn about the edges of our universe. Down on Earth, the questions of control are just as sharp, from the government's limited release of Anthropic's Mythos model to the Linux Foundation's new Akrites coalition. In every case, whether it is biology, physics, or software, we are watching the early days of some major transitions. We have got more build cues and science updates lined up for our upcoming sessions. Keep your skepticism calibrated, and we will pick up the signal when the next episode drops.
It's certainly a lot to consider. If we missed an angle, or you have further questions on these topics, please drop us a comment. We read them down here in the tunnel. And if this signal helped you stay informed, a like or subscribe keeps the pipes humming. More surface news and deeper dives are coming through the grate soon. Until then, stay curious, and we'll catch you next time on The Low Band Show.